Hey guys, I'm Valen and welcome to day 10 of Advent of Code. Like I said in the episode yesterday, I will limit myself from now on to 2 hours because I'll spend way too much time on this. So let's start with part 1. You all arrive at a lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your inputs, and looks up at you excitedly. Perhaps you can help fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from 0 lowest to 9 highest. For example, 0, 1, 2, 3, 1, 2, 3, 4, 8, 7, 6, 5, 9, 8, 7, 6. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0 and ends at height 9 and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left and right from the perspective of the map. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Here these positions will always have height 0. Assembling more fragments of pages, you establish that a trailhead's score is a number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9. The one in the bottom left. This trailhead has a score of 2 because there are 2 9s that can be reached from it. The positions marked dots are impassable tiles to simplify these examples. They do not appear on your actual topographic map. This trailhead has a score of 4 because every 9 is reachable via a hiking trail except the one immediately to the left of the trailhead. This topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. Here's a larger example. This larger example has 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of the scores of all trailheads is 36. The reindeer gleefully carries over a protractor and adds it to the pile. What is the sum of the scores of all trailheads on your topographic map? Okay, so my first idea was to start looking for all the 9s and trying to go down the path and seeing if you can find a 0, but because we need to get the trailheads and like count how do we do this? I think I have an idea how to solve this, so let's quickly work out my plan. So we start finding the 9s. We check every possible route from the 9s. When ending on a 0, we add +1 in dictionary with as key the position. So I think that will be the best way of doing this. Start finding the 9s. We check every possible route from the 9s. So to check every possible route, we need to go through every single path possible. So check surroundings at each square. So you check the surroundings at each square and calculate all possible solutions. So I think we need a recurring function. So func check path. We need a position, so a pos, which is a vector to I, and we need a height, which is an integer. And basically we just take all the 9s and then put the 9s inside of here, and we let that code do all the calculations. I think this will be the best way to go about this, and I think I have a good plan this time. Unlike yesterday, And they have scores of... Yeah. Okay, so I'll start work on that. I'll see you in a bit. Okay, so I took some time to write the code. I have not tested it yet, but part 1, so we create the data, we create the total, and then we go through a loop of the y's, so every string inside of the array, and then over every character with the x. Then, because of how arrays work, we need to do yx to get the line and to get the character in the line. If that is 9, we create a new array, trailheads, because we go from 9 to 0. I think we could probably go the other way as well, but I set my mind on 9 with making this plan here. I know I was reading this whole thing. They talked about the 9. I saw a lot of 9, so I basically thought from, okay, let's go from 9. Maybe a wrong idea, but yeah. So we check the paths. We pass L data, the position where we are at right now, the 9 position. Then L trailheads, the empty array, and 9. Because we pass an empty array, we directly have access to this array, and all instances of that function will be able to read that data. Oh, by the way, of how, because when you pass an array in Godot, it's more like you pass a pointer to the object. Same for the dictionary. So yeah, I'm kind of using these kind of things to my advantage in here. So the L value, because we need to add up the data. Next up, we add the trailheads to the position if they don't exist, and we return 1. If it already exists, I don't think we need to add it if it already exists. Then we check up, and we basically take the part up, and we make certain that it's within the array, within the map. And then we just do the exact same function. So basically this function loops over and over and over until we find a 0. If we don't find a 0, we just return the L value, which is by default also a 0. If this one, by example, returns +1 or +5 because it's found different exits, then L value will be a bigger number, but we return everything. So everything slowly adds up together, and instead of calculate results, we don't really need this. I made this, but we directly add everything together. And then here I kind of prepared for the second one already. Let's just return 0. Let's quickly run this. And we got 36, and there's 36. So let's quickly do the data. It's surprising how well everything goes if you plan everything and just plan everything in advance a little bit. Let's hope. Okay, so that's the right answer. You are 1 gold star closer to finding a chief historian. So continue to part 2. This is going great right now. It's still been an hour or so, but yeah. Basically, I'm planning more, and I'm not running the function as much to like test things, because I first want everything on point and not test halfway through, because then I will change my mind and not follow my plan anymore that I made out for myself. So yeah. We can delete this one right now. Maybe let's just have that as like documentation for part 1. Okay, and part 2. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trailhead. For example, 0, 1, 2, 3, 4. Okay, so the above map has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails, which begin at position 10, 10, 10, 10. Here is a map containing a single trailhead with 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this map contains a single trailhead with rating 277 because there are 121 distinct hiking trails that lead up to 9. Really? Oh, okay. That lead up to 9 on the right edge and 106 that lead to the 9 on the bottom edge. Here's a larger example from before. Considering its trailhead in reading order, they have ratings of 20, 24, 10, 4, 1, 4, 5, 8, and 5. The sum of all trailheads rating in this larger example topographic map is 81. You're not sure how, but the reindeer seems to have crafted some tiny flags out of toothpicks and a bit of paper and is using them to mark trailheads on your topographic map. What is the sum of the ratings of all trailheads? Wait, isn't that what I was already doing? The above map has a single trailhead, its rating is 3 because there are exactly 3 distinct routes. So wait, what is then the test result? The test result is 81. And we're basically counting every root, so let's just add an extra bool. I think I can fix this very quickly. So a all bool is false. And in here, let's just copy this. Let's put this here. And in here, let's put this to false. If a all is true, then we just return 1. And let's take the test data again. So this returns 36 now. Oh yeah, this will be true. Still returns 36. What are we doing wrong? Okay, this will probably take a little bit of time. Okay, no, I actually know what I was doing wrong. So this says a all false, but we don't really like do this. So this should, because I put the argument by default on false. So I should have done this instead and just not be lazy and put false in here. Because I think this will work if I just do this. If a all, and I think this will work. So a all, and we just pass the exact same value here the whole time. Let's paste this, let's paste this. Let's run this, and I think we got the answer already. Wait, why is part 1 81 now? Oh yeah, negative. Whoa, can I finish within an hour? I started at 2:34 something. Okay, so if we change this now to normal data, and whoops, let's run this. Okay, I think this may be correct. If it's not correct, then I have 1 more hour. I really need to plan more. I really need to plan more and first write out my plan that I made instead of switching halfway through. This is what I should have done the past couple of days. So yeah, I'm done for today and in less than an hour. That's a new record, I think. So yeah, anyway, thank you all for watching. Thanks my Ko-fi supporters for supporting me through everything. I still work on GoZen every morning, so GoZen Alpha will come kind of soon, I think. There's a whole rework of like how I show the images and how I render the images out, but that's almost done. So yeah, anyway, thanks for watching and I'll see you all in tomorrow's episode, day 11 of Advent of Code. Bye bye.